Hello, welcome to our YouTube channel where we're providing mathematics for people that are writing their GC exams, school certificate exams, and even grade 9s are also going to be covered in this channel. So today we are looking at geometric progression, which is part of sequence and series. Now we are done with the 8P, which is arithmetic progression. Now we have moved to geometric progression, and that is what I want to deal with, the first part of geometric progression today. So what is it that is involved here? As you can see, the definition is given here that it is a sequence in which each term is formed by multiplying the previous term by a constant amount. So there are words here that we have to note. Constant, multiplying constant. Okay? So to get the next term, you need to multiply the previous one by a constant. And this constant is what we are calling a common ratio. For an 8P, we are calling it a common difference. Now here, we are calling it a common ratio. If you remember, for the common difference, which was denoted by the letter D, the formula was T1 minus T2. Now for the GP, which is geometric progression, I'll keep referring it to as GP, which you must know that it's geometric progression. Now for a GP, it's the second term divided by the first term. Third term divided by the second term. If it's the fifth term, it's fifth term divided by the fourth term. It goes on like that. All right? So that is the point. And how do we find so we have noted here that this is the formula that we use to find the common ratio. The common ratio. That is the formula that we use to find the common ratio. Okay? That's the formula that we use to find the common ratio. So, how do we proceed now? We have an example here. We have an example that we are supposed we have examples that we are supposed to work out. Find the common difference. Find the common difference. Find the common difference. Please, you have to make sure that, like I keep saying, you need to have a proper book where we write all these things nicely. But even an exercise, you do it. So, common ratio, which is denoted by the letter R, is equals to the second term divided by the first term. In this case, for the first one, which is A, the first term, the second term is 4, which is divided by the first term, which is 1. And this is going to give us 4 as our R, which is common ratio. If you want, another person is going to say, I'm going to use T3 divided by T2. That person will use 16 divided by 4. What is that person going to get? It will still be what? 16. Another person could choose to use T4, which is the fourth term, divided by you will still get what? 4. Alright? You still get 64 divided by 16, you get 64. So that is the common ratio for the first one. Let's come to the second one. The same formula applies even to the second one. It's the second term divided by the first term. The second term in this case is 1 over 2. Divided by the second term, the second term is 1 over 2 divided by 1 over 4. Divided by the first term, which is 1 over 2. Now, we all know the rules of division of fractions, that we need to multiply the first fraction by the reciprocal of the second one. This one, we get its reciprocal. So when you simplify this one, it's going to give us 2 over 4, which is going to simplify as 1 over 2. Okay? This is our R, which is the common ratio. If you want, you can also try this one, which is going to be T3 divided by T2. 8 divided by 1 over 4, which will be 1 over 8 multiplied by 4 over 1. 4 here is 1, 4 here is 2, which is going to reduce also to 1 over 2, the same as this one. So what are we saying? The common ratio for the second GP is 1 over 2. 1 over 2 or 0.5 or 0.5 or 0.5. That is what we are doing here. All right? Now, we go on to the second question. What is the second question saying? The second question is saying, you're given these sequences here. You're given the sequences. But then the question is saying, can you find out, do investigate and establish whether each one of these is a GP, is a GP. That is what we want to do. So what are we supposed to do to establish that? We are supposed to say the common, you know that this is the formula that we use to find the common ratio. So if this one is going to be equal to also this one, T2 divided by this one, this gives us, if we also find the same here, which is the common ratio, then we are going to conclude, okay, that this is a GP or geometric progression. So we can begin with the first one. Here. Our T2, which is the second term, is 6 divided by the first term, which is 3. This is equals to, the third term is 12 divided by 6. This reduces to 2. This also reduces to 2. These two are equal. If the two are equal, then what we have is a GP. So this is, it's a GP, this one. All right? This is a GP. What about the second one? The second one, we are applying the same formula. So what are we saying on the second one? T2 is 4 divided by 1. Then 7 divided by 4. When you look at this, these are not equal. These are two different fractions. We have 4 this side, which is, so these are not equal. Therefore, this is not a GP. So the second one is not a GP. So this is the process that you have to carry out for all these. So let me do one more. Okay? Let me do one more, which is C. On this part, let me do C. So we are saying the second term, which is 1 over 3, has to be divided by the first term, which is 1 over 2. And this should be equal to, when the third term, which is 2 over 9, is also divided by the second term, which is 1 over 3. So we have to work out these things. If they are equal, then we can make the conclusion that it's a GP. If they are not, then it's not. All right. So we go on and simplify this. This is going to be 1 over 3 multiplied by 2 over 1, if you like, or you can just write it as 2. Then this is going to be 2 over 9 multiplied by 3 over 1. So I'm going to write this as 2 over 3. Sorry, 2 over 3. This is equals to 6 over 9. 6 over 9. Now, when you look at these two, these are equivalent fractions. These are equivalent fractions because This is going to be simplified. If you want to simplify this one, you are going to say there 3 can go into this one 2 times, 3 can go into this one 3 times. At this point, these are equal. Or even so, these are equivalent fractions. So in that case, when you've got equivalent fractions, you have a GP. Do not say these two are not equal, hence it's not a GP. That would be wrong. This is a GP because this one can reduce to the other one, hence equal. All right. So I have done the first 3, and I expect you to do 1, 2, 3, 4 to prove. But one thing that you have to note is that the process for finding the common ratio is you divide the second term by the first term, or the third term by the second term, or the fifth term by the fourth term. Goes on like that. All right. So let me go to question 3, and I want to make this my last example. Then yourselves are going also to do these ones here because it's a repetition of the question that I'm going to demonstrate here. So I'm going to demonstrate the process that you have to carry out on this one. Then that is basically what you are going to do. So, all right. Please write down these questions like I've said, or you are going to come and copy them later, these questions. Okay? So this part I can say we are done. You know what you're supposed to do, and you saw what I have done. All right? I'm only facilitating, the work belongs to you. So, we have the first 3 terms of the GP, and we want to find this value of x. What are we supposed to do? This is where we are saying we need to use the same method that we've been using here. What is the method? This same one. This method is very important. Please, let's do practice. This method is very important and helpful to you. So we need to apply this method. It will help us to find the value of x. Remember, the value of x is not the common ratio. The common ratio is found by a formula that we have given. So we are going to use this formula here, which is the second term divided by the first term. This must be equals third term divided by the second term. Third term. So when this is our first term, this is our first term here, our second term, and our third term. So our second term is 3 is x plus 3 over x plus 1, which is equals to x plus 8 over x plus 3. We want to find a value of x. What are we supposed to do? We need to go on now. So we cross multiply. That is how we simplify, or that is how we solve equations of this nature. Now we are looking at equation. So 3x plus 3 multiplied by x plus 3. We cross multiply this by this other. So it's going to be x plus 3 multiplied by x plus 3. This must be equated to x plus 1 multiplied by x plus 8. Alright, then we begin to simplify. That is why I keep emphasizing that it's very important that you understand where we're coming from, because these things were adequately covered in algebra, how to multiply this kind of terms. So you multiply x by x, you have x squared, x by 3, you have 3x, 3 by x, you have 3x again, 3 by 3, you have 9. This is equals to the same thing here, x squared plus 8x, then here plus 8, all right? This one, this one, this, so then we have 8. Okay, so now we can begin to simplify these things. For me, I feel that when you look at here, we have x squared and x squared here. So these two is like we can get rid of them, because if this one comes this side, it will be a minus, so it will give us a 0. So we can get rid of those, the x squared, because they have the same coefficient. So when we take them on one side of the equation, they will cancel and they're going to give us a 0. So I'm going to, in other words, we're saying it's like we are collecting the like terms together. But what we are saying is that you know that the additive inverse of this one, it's a minus, so it will be 0. So I'm going to leave out these ones here, suggesting that we have simplified them and they gave us a 0. Okay? Then I'll move on with 6x plus 9. This is equals to 9x plus 8. Okay? I hope we are together there. I hope we are together. So, this is what we are supposed to do. So, we are solving now for, so I'm going to say 6x, the additive inverse of plus 9x is minus, then here we have, this is minus 9. Okay? The additive inverse of this one, when it goes the other side, like we always do explain. When it crosses the equal sign, in the actual sense, we are looking at the additive inverse. All right? So this is minus 3x is equals to minus 1. Then now we want to look at the value of x. We all know that it will be minus 1 over minus 3, which is going to be equals to 1 over 3. So the value of x is equals to 1 over 3. This is the value of x. The value of x is not a common ratio. The value of x is not a common ratio. So we need to look at the common ratio separately. Okay? So please get to know, as we move to the next lesson or the subsequent lessons that will come after this one, these concepts will be applicable and very helpful with the understanding, because I will less emphasize them in the lessons to come. I'll take it that they were adequately represented here and you got a concept. So make sure you get this, because now we're going to look at combined questions later on where these concepts will be needed. Okay? So let's look at the last part, which is the common ratio. The common ratio, take into consideration that your x is 1 over 3. Now you know that one of these formulas here, or both of them, what are they giving us? They are actually giving us the common ratio here. This is the common ratio. This is the common ratio. So if I want, I'm going to get, because you know that common ratio is equal to what? T2 divided by T1, which is what we carried out here. So I'm going to bring these things here. 3x plus 3 over x plus 1. Then I begin to replace. Because now we know what x is. We know what x is. We can say up there we're going to have 1 over 3 plus 3 over 1 over 3 plus 1. So we work out these fractions now. We work out these fractions here. We work out these fractions so that we get, so if you want, we get 1 over 3 plus 3 plus 3. What do we get? We have 3. 3 into 3, it's 1. 1 multiplied by 1 is, here we have 3, isn't it? We have 1 into 3, it is 3. 3 multiplied by 3 is 9. So this gives us what? 10 over 3. I hope that is clear. I'm looking at the one that is on top here. So this is 10 over 3. Take note, we have divided by this one here. What is it? 1 over 3 plus 1. Again. 3 into 3 is 1. 1 multiplied by, what do we get? 1. Plus this one. What do we get? It's 3. 3 multiplied by 1? 3. So this gives us 4 over 3. So down here, what do we have? 4 over 3. I hope you are following me. I hope you are following me. So in other words, what this means is that we have 10 over 3 divided by 4 over 3. This is going to go on as 10 over 3. It's going to go on as 10 over 3. My marker is getting, so let's say 3 multiplied by 3 over 4. Okay? We change this one, then you know now, by now you know. So this and that, so we have 10 over 4, and you have 5 over 2. This is what is going to be our R. In most cases, I do advise that do not convert it into a mixed number, because in terms of exam questions, usually from this point there will be other questions that will follow, and it's more convenient using it as it is like this, because at some point you'll be required to take it back. So this is our common ratio. So take note, the value of our x is what? We got 1 over 3, and our R, which is common ratio, is 5 over 2. So if now you want to find the actual terms, you need to just be replacing those, okay? Now you have our common ratio, and you know what our first term is. If you want to know now exactly what our first term is, our first term, I think we worked it out as this. Which one was our first term? I think this one, if I'm not mistaken. Yes, this one. So this is our first term. This is our first term. So you know our first term and now stuff like that. All right. So basically, I gave you in the part that I wrapped, there are questions that I asked you to do. And these ones, okay, I said on each of these are the first 3 terms of a GP. So on this one, find the value of x, find the common ratio, all right? The same thing even here. The same thing even here. That is what I want you to do. That is what I want you to do. So, thank you so much for watching. I hope you are subscribing to this channel so that you see all the videos that we are uploading. Otherwise, we are committed to providing you with the best services that we can afford to provide. All right? So make sure that you do the questions, those ones and these ones. Here you are finding there. It's actually exactly the same process that I carried out here. Okay. Thank you very much. Until next time.